Hey guys, it's Miss Meneely, and I'm sorry I'm not with you again today. In fact, I'm going to be out all week, excuse me, because I have the flu. So I apologize for not being here today. I am going to try to get through the lesson as best I can. Um, and obviously, if you're confused about it, we will fix everything next week. I just didn't want to lose instructional time with me being out this week. So the warm-up that you guys have kind of combines a couple things that we've done. You've got the special right triangles, and I think you can tell. Actually, I've got another slide that just to remind you what our special relationships are. If you have a 45, 45, 90-degree triangle, we know that it's got to be an isosceles triangle since the two angles are the same measure and that the legs have to be the same length. Then we know that the hypotenuse is simply equal to the leg times the square root of 2. If we know the hypotenuse and we don't know the leg, we can certainly find it by just taking the hypotenuse times the square root of 2 over 2. So if you take a look at number 1, and I apologize, I'm doing this at home on my laptop, so my handwriting isn't going to look as good as it usually does when I'm able to do this on my smartboard, so I hope you can forgive me. If we take a look at number 1, I think the easiest thing to find first is that angle Z. I think it's pretty obvious that since this is a right triangle and one of the angles is 45, that the measure of angle Z has to also be 45 degrees. Sorry, my handwriting isn't very good. All right, and if I want to find the values of x and y, I know they're both going to be the same, so I can actually just say x equals y. And that is going to equal, well, if I know my hypotenuse and I'm trying to find my leg, I know that my leg is just going to equal the hypotenuse times the square root of 2 over 2. Since my hypotenuse is 1, I'm simply multiplying 1 times the square root of 2 over 2. And if you think about it, if I multiply anything by 1, I just get the quantity again. So both of those sides are going to be the square root of 2 over 2. Sorry, that's kind of sloppy. All right, and that's going to be my side length. This is really important because we're actually going to be shifting from using triangles to talking about circles and looking at our trig functions, our sine, our cosine, and our tangent with respect to what's called a unit circle. And so these fractions that we keep seeing, the square root of 2 over 2 and the square root of 3 over 2, we're going to see those relationships over and over and over again. Let's take a look at number 3. This is another special right triangle. We know we have the 90 degrees here, the 30 degrees here, so that leaves Z to be a 60-degree angle. Sorry. There we go. And so again, I know the hypotenuse is 1, and if I look at my relationship for the 30, 60, 90 degree, it says the short leg is going to equal the long leg times the square root of 3 over 2. Well, I don't know the long leg, so that doesn't really help me. But I also have this relationship up here where the hypotenuse is equal to 2 times the short leg. Well, that must mean that the short leg is equal to half of the hypotenuse. So y must equal 1/2 times 1, or simply 1/2. And once I know the value of y, I know that the long side, which we're calling x, is going to be the short leg times the square root of 3. So that's going to be 1/2 times the square root of 3. And what I want to do is kind of write this as a single fraction. The square root of 3 is the same thing as the square root of 3 over 1. And so I can just multiply across the top, and I'm going to get the square root of 3 over 2. And so, again, we're going to see this fraction a lot. Let's take a look at the last one. If you take a look, this time we've got the triangle kind of flipped, but notice that it is another 30, 60, 90 degree angle. But this time we know the 60 degree angle. That must mean that Z in this case is 30. And notice in this problem, we're just using degrees. We're going to go back and look at radians in a little bit as well. And so we know from that relationship, the right side of our table, that the hypotenuse is going to be the short leg times 2, or that our short leg, in this case is x, is going to be half of our hypotenuse. So x must be 1/2. And y, just like we saw above, if I multiply 1/2 times the square root of 3, I'm going to get the square root of 2. And these relationships are really important because what you'll notice is that for a 30, 60, 90 degree triangle, the 1/2 and the square root of 3 always go together. And for the 45 degree angles, the square root of 2/2 is going to be the same for both legs. Okay, so in today's lesson, we are going to be moving from right triangles to circles, specifically what's called the unit circle. And we're also going to return to looking at degrees and radians. We're also going to talk a little bit about sine, cosine, and tangent. So if you guys could take a look at your classwork, we are going to kind of complete this together. So your class notes should look like this, but I also need you to have a copy of the unit circle. And the unit circle that you should have, because we're going to kind of flip back and forth, you should have something that looks like this. This is a blank unit circle. And we're going to start constructing it in class today. So let's go ahead back to our beginning. Okay, so there are 6 basic trig functions that we're going to use over and over throughout the course. We're going to discuss the first 3 today. And there's 2 ways that we can define these functions, each having its own advantages and disadvantages. The first way that we will do, we will look at trig functions as points on the unit circle. So what is a unit circle? So a unit circle is simply a circle that has a radius of 1. It is centered around the origin. So this point right here is the ordered pair. Oh, sorry, actually write it down here. This is the origin, 0, 0. Okay. And so, like I said, the radius of my circle is going to be 1. So if we construct a ray, and actually let me do this in another color. If we construct a ray from the origin of the circle to the outside of the circle, and then we are creating, if we think about it in standard position, we are creating this angle that we're going to call theta. And this is going to be our reference angle. Okay. The point where our ray hits the circle right here is going to be an ordered pair. So I'm going to call it XY. But we're going to see that we can also look at it from a different perspective in a little bit. Okay. And then from this point, we can also drop an altitude. And this is going to form a right angle with our x-axis. And so because the unit circle has a radius of 1, I know that my hypotenuse must be 1. And then if we think about the lengths of the sides of my triangle, so like here's my point XY, right? So the length of the base of my triangle is actually going to be the value of x. And the height of my triangle, if you think about the y-axis, this is going to correspond to the value of y in my ordered pair. And essentially what we're going to do is we're going to look at some really common angles, and then we're going to identify all the points x, y that are associated with it. All right. So let's talk about the 4 most obvious points. We already said that the point in the center is the origin, and that we know that the radius of our circle is 1. So let's go ahead and label this point right here. If my radius is 1, then this point right here is the ordered pair 1, 0. And then what about this point up here? In this case, the x value is 0. And the y value is 1. And if I come over here, right, this is going to have an x value of -1 and a y value of 0. And then down here, we're going to have 0 and -1. Okay, so hopefully that's pretty obvious. Okay, what I'd like you to do now is go to your unit circle. Okay, go to this blank unit circle, and let's go ahead and start filling it in. Okay, so what we've filled in, let's see, I think it might actually be faster for me. So this is going to be the point. 1, no it's not. Sorry. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now you'll notice that there are a bunch of other lines on the graph, on the unit circle, the dotted line and the solid line. I'm also going to go ahead and identify the angle measures in both degrees and in radians. So for example, if I just think of this, this angle right here where my initial side and my terminal side are the same, that means I'm going to have an angle of 0 degrees. And that would also correspond, if I'm thinking about 0 degrees and I change that into radians, remember our whole circle is 2 pi radians. So an angle that has an initial and a terminal side the same is just going to be 0 pi. Okay. Now if I were to go all the way around the circle, this angle would also correspond to 360 degrees. And if we think about the circumference of a circle, it would also correspond to 2 pi radians. So if this angle, 0 degrees, corresponds to 2 pi, if I think about this angle over here, oops, that was a horrible straight line. Try that again. Okay, that's just a straight line. And that I know is going to correspond to 180 degrees. And if I'm counting my pi's, remember the whole circle is 2 pi. So if this is half the circle, this is just going to be 1 pi. Okay. And now let's go ahead and identify the angles that correspond to my maximum and my minimum points. I know this is a right angle. So that means that this is going to correspond to 90 degrees. And if I think in terms of my radians, so if half of the circle is pi, then a quarter of the circle would have to be pi over 2, or half of pi. We just write everything in terms of, well, that was horrible. We're going to write everything in terms of a fraction. So I'm going to leave it as pi over 2. Okay, so this is 0 pi. This is half pi. This is 1 pi. So down here must be 1.5 pi. And 1.5 pi is the same as 3 pi over 2. So that's what I'm going to write here. 3 pi over 2. And in terms of my degree measure, so this is 90 degrees. This is another 90 degrees. So now I'm at 180. If I add another 90 degrees, this is going to correspond to 270. Okay? So this is what your unit circle should look like so far. All right. So let's go back to our class notes. All right. So we're going to look at the most common angles in a unit circle. So the 30-degree angle, the 45-degree angle, and the 60-degree angle, in addition to the 4 angles that we just looked at. So let's take a look at our 30-degree angle. So if I want to convert it into radians, remember we said if it starts off with the degrees and I want to make it radians, I need to multiply it by the pi of 180. Okay. And 30 divided by 180, when you change it to a fraction, is going to end up being pi over 6. Okay? So this angle here is going to be equivalent to pi over 6. And what do we know about the relationship between the sides of a 30, 60, 90 triangle? Remember, we said that this has a hypotenuse of 1, And if we go back to our warm-up, when we look at a triangle that has our angle at 30, the short side, we said, is just going to be 1/2 of the hypotenuse. And since my hypotenuse is 1, this is going to be 1/2. And the length of my longer side, I'm just going to multiply that by the square root of 3. So we get the square root of 3 over 2. And these become the ordered pair of this point right here. So let's go to our unit circle and plug that in. Okay, so this first angle that we're looking at, let me do this in a different color. This in red. We're going to look at a 30-degree angle here. And we said a 30-degree angle is going to be the same as pi over 6. And remember, we said the x side, the long side in this case, is the square root of 3 over 2. Sorry, my handwriting is so bad on this. And the y value is going to be 1/2 because that's actually the shorter side. Well, I can actually identify 4 other points on the circle that are going to correspond to this angle. And is going to have a similar set of ordered pairs. So all I'm doing is I'm dropping these lines to create this like rectangle. Because essentially, this angle here is also going to be 30 degrees. And so if I go back, if this straight line is 180 degrees, then this angle right here is going to be 30 less. So this angle right here is going to be 150 degrees. And there's 2 ways that you can change that to radians. You can multiply it by pi over 180, or we can actually count our pi over 6s. So if I take a look, this is 30 degrees, and that's 1 pi over 6. Well, another 30 degrees is this angle right here. So that would actually be 2 pi over 6. If I go another 30 degrees, I'd be at 3 pi over 6, which actually is going to reduce to pi over 2. And if I go another 30 degrees, that would be 4 pi over 6. And so this 30 degrees actually corresponds to 5 pi over 6. And if I were to go another pi over 6, I'd have 6 pi over 6, which reduces to pi. But again, if that doesn't make sense to you, simply multiply 150 times pi over 180, and it's going to reduce to 5 pi over 6. The other nice thing about the symmetry here is I know that the height of my y value has to be the same height as here. So the y value for this angle is also going to be 1/2. Because if I think about, remember, this is my x-axis and this is my y-axis. So if I'm thinking of the points along the unit circle, these are going to have the same y values. So think about what would have to be true about the x values. I'm over here on the positive side of x. So if I come over here, this should have to be a negative square root of 3. Oops. Over 2. And if I come down here to this point, this is now quadrant 3. So I don't know if you guys remember this from Algebra 1, but we have 4 quadrants. So let me actually do this in another color. We do this in a highlighter. So this is quadrant 1. We go counterclockwise. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Oops. Okay. All right, so if I go back down to this point here, again, the x and the y values are going to have the same absolute value, but the signs of the numbers are going to depend on what quadrant they're in. So in quadrant 3, both values are going to be negative. So this is going to be the negative, negative square root of 3 over 2. And negative 1/2. And if I move over here, my x value is going to be positive again. So this is going to be a positive square root of 3 over 2. And a negative 1/2. Okay, so that gives me the ordered pairs, but it doesn't really help me with the angles. So again, I'm just thinking that these 4 points are 30 degrees away from my horizontal x-axis. So if this is a 360-degree angle, this must be a 330-degree angle. And if this is 180, this is going to be 30 degrees more. So this is going to be a 210-degree angle. And then when it comes to dealing with my pi over 6s, I'm going to keep counting. So we said this is 5 pi over 6. This would be 6 pi over 6. Well, this point here is going to end up being 7 pi over 6. Oh, that looks like a terrible 6. Okay? And then this point here would be 8 pi over 6. This would be 9 pi over 6, 10 pi over 6. And this point here is going to end up being 11 pi over 6. Or, if you think about it, this is 2 pi, which is the same thing as 12 pi over 6. And if I subtract it 1/6, I'm left back with 11 pi over 6. Okay, so let's go ahead back and take a look at our 60-degree angles. Actually, I think we might look at our 45-degree angles. So remember, if it's a 45-degree angle, when we convert this to radians, so if we have, if we take, let me do this in another color, so this is blue. So if I've got 45 degrees and I convert to radians, remember we're multiplying by pi over 180. And if I do this, I'm going to end up with pi over 4. So a 45-degree angle is going to be equivalent to pi over 4. And one of the things that we know about a right triangle, if it's 45, 45, 90, and it has a hypotenuse of 1, again, when we go back to our warm-up, we learned that both of the sides are going to be the square root of 2 over 2. Okay, so this side here is going to be the square root of 2 over 2. And this side here is going to be the square root of 2 over 2. So that means that the point on my circle, right here, for both x and y, those coordinates are going to be the square root of 2 over 2. So let's go ahead and fill in our unit circle. And again, I'm going to do this in blue now. And we're looking for our 45-degree angles now. So we're going up another 15 degrees. So right above the 30-degree, I know this is going to be a 45-degree angle. And it's kind of cutting my quadrants in half. So this would be 90. And then if I add another 45, this is going to be 135 degrees. And if I add 45, it'll give me 180. And if I add 45, this is going to give me 225. And if I add 45, I get to 270. And if I add 45 again, it's going to be this angle here. This is going to be 305. Okay. And if we think about my radians, we said this is 1 pi over 4, right? Pi over 4. So this angle here, which is just another 45, is going to be 2 pi over 4. Well, 2 pi over 4 is going to reduce to pi over 2. This 45-degree angle is going to correspond to 3 pi over 4. And then the other 45 will be 4 pi over 4, which again reduces to 1. This is going to be 5 pi over 4. This is going to be 6 pi over 4, but again, that reduces to 3/2. And then this angle here is going to be 7 pi over 4. Okay. And we said that the x and the y coordinates for this point are just going to be the square root of 2 over 2. And this is in quadrant 1. So if I go to quadrant 2, the x value has to be negative. So this is going to be a negative square root of 2 over 2. And a positive square root of 2 over 2. Sorry, I'm going to give you a clean one of these. So if you're worried about not copying it right, you'll get a clean copy of it. Okay. In quadrant 3, we know that both points are negative, or both values are going to be negative. So this is going to be negative square root of 2 over 2. And negative square root of 2 over 2. I'm starting to merge into the next part, sorry. Oops. Okay. And then in my fourth quadrant, my x value is going to be positive. But my y value will still be negative. Okay. All right. And then our last angle, if you can imagine, we've done the 30 and the 45. So this angle is actually going to be our 60-degree angle. So let's just go ahead and do it. Let's do this in, let's see, what color can I use? I'll do it in like a orange. All right, so this is going to be our 60-degree angle. Oops. And so if I think about it, 60 plus 60 plus 60 is going to give me 180. So this angle is actually going to be 120 degrees. And then if I add 60, I'm at 180. If I add 60 again, I'm at 240. This is a 240-degree angle. If I add 60, I'm at 300. And then if I add 60 again, I'm all the way around the circle. If I think about writing these in radians, so let's think 60 degrees times pi over 180. Well, that's just going to reduce to pi over 3. So this is going to be pi over 3. This is going to be 2 pi over 3. If I go another 60, that's going to be 3 pi over 3, which is just 1. This is going to be 4 pi over 3. Five pi over 3. And then 6 pi over 3 is again going to reduce to 2 pi. And if we think about our ordered pairs, remember with the 30, 60, 90, I'm just going to switch the two sides. So the x value here is going to be the shorter side. And so for the coordinates at this point, it's going to be 1/2, and this is going to be the square root of 3 over 2. If I go into quadrant 2, my x value has to be negative, so it'll be negative 1/2. But my y value will still be the square root of 3 over 2. In quadrant 3, everything will be negative. So I'm going to have negative 1/2 and negative square root of 3 over 3. I'm sorry, square root of 3 over 2. And in my fourth quadrant, my x value is going to be positive again, so it'll be 1/2 and a negative square root of 3 over 2. Okay. I know that looks a mess. So let me go ahead and give you a completed version of what a unit circle should look like. Okay, so if you need to fix anything, in fact, for your homework, I'm going to give you a completed unit circle, and I'm just going to ask you basic questions. For example, let's see, what would be the coordinates of the point that would be associated with a 135-degree angle? So if I find my 135 degrees on my unit circle, and I want to find the ordered pair associated with it, it's just going to be that ordered pair. I could also give you an ordered pair. So for example, let's say I give you the square root of 3 over 2 and -1/2, and I ask you to give me the angle. Well, you should be able to tell me it's a 330-degree angle, so you should be able to give it to me in degrees or in radians, 11 pi over 6. And that's really all I'm asking you to do at this point, is just being able to interpret the unit circle. We're actually going to construct it over and over and over again, and believe it or not, I know this sounds scary, but you guys are going to be able to construct this all by yourself. I know you don't believe me, but I promise you will. In fact, anybody that wants to race me next week, I will give you extra credit if you can beat me in constructing this thing. I've had kids that can actually construct it in less than 2 minutes. So that is my challenge to you, is while you're working on your practice and while you're working on your homework, I want you to look for some patterns, okay? And then when we come back and talk about this next week, we'll talk about those patterns, and we'll see if we can reconstruct this a little bit easier and a lot faster. But again, I'm not going to worry about this right now. We'll talk about the sine and the cosine of those angles next class. Right now, I just want you to be able to identify, like if I ask you what point is, corresponds to a 360-degree angle, you should be able to tell me it's the ordered pair 1, 0. If I say, what corresponds to a -90-degree angle, remember, if we have a negative angle, that means we're going backwards. So a -90-degree angle actually is going to correspond to a 270-degree angle. And so the ordered pair would be 0, -1. Okay. So on your homework, I'm going to give you a completed unit circle. So you actually have a really clean one with all the correct answers on it. And then on the front side, I'm just going to want you to identify the points and the angles in both radians and degrees. And I really want you to look for some patterns that emerge. Okay? And again, we'll talk about this next week. Don't panic if you're nervous. I promise. I promise. It will come together very simply. And actually, this is one of those quizzes that students love, because it's a really easy A. And once you know the patterns, it's super easy. I know you don't believe me now, though. Anyway, good luck, and I will see you next week.